Thank you for joining the Resilient Cyber Show. My name is Chris Hughes, and today I'm joined by Varun Badhwar. Varun, thanks for being here.
Excited to be here with you, Chris, again.
Yeah, again, because we've had you on in the past, but for folks that don't know you, don't know the Endor Labs team, which shouldn't be many if you've been following me for some time, but for folks that don't know you and the team, can you tell us a bit about yourself as well as Endor Labs?
Yeah, certainly. So I've been in the cybersecurity space almost 20 years now. Started out in security consulting, got lucky to become one of the first security professionals at Salesforce.com, built and scaled one of the largest enterprise cloud platforms out there for about 4 years. And then I got the bug to go build companies. And I think that the kind of leg up I had on most of the industry is I was seeing cloud security inside out long before most people were thinking about it. And starting in 2010, I've been building companies. First one was a company called Cypher Cloud in helping enterprises securely adopt SaaS applications like Salesforce. 2015 saw the rise of kind of the movement from data centers to cloud platforms and went and started Redlock long before CSPM was a big thing. We created that category, kind of got acquired by Palo Alto Networks in 2018, and then built Prisma Cloud and the evolution of CNAP. Uh, did that till about 2021 when my own team got hit by two software supply chain incidents. The big one everybody knows around SolarWinds, and then a little known one, CodeCov. And I'm like scratching my head. I'm like, we never talked about software supply chain security, and now all of a sudden, there's stuff happening all over the place. And that took me down the deep end of the pool to kind of get a better understanding of software supply chain and how we write software. And like the biggest takeaway for me is we don't write software, we assemble software. 80% of the code is really not written by our developers, borrowed from completely untrusted sources on the internet, as spooky as that sounds. And so we embarked on the journey to go better understand application security and how and where it was working, where it was breaking. And clearly, the number one breaking point was the tax on developers for meeting application security requirements was simply too high. So the fact that we want to fix all of these things in shift left, we run all of these tools, but these tools are generating millions of alerts in an enterprise every year. And there's no engineering team in the world that can keep up with that velocity of problems being identified. And then you have the other side of pressure on SLAs to fix, right? FedRAMP, PCI, 30-day fixes for criticals and highs. And you simply don't appreciate that engineering wise, you can't go upgrade Java Spring in 30 days. So like there's just irrational how things were going. And we said like there's got to be a better way. And so late 2021, we started Endor Labs with a mission to really bring precision, bring actionability and fixability, and really kind of build a flywheel of how you are finding things on the left, but really finding the 5% of the things that matter, not all this noise that comes with it. How do you get developers to fix it really, really fast? And as we're going to get into more and more, little did we know at the time that all of the stuff that we had been building our IP around and our proprietary data set around open source software would become the foundation for AI coding, because every model on the planet now that produces software is trained on open source. And it just turns out we have the best insights, the best technology, and I won't get ahead of ourselves, but essentially, we're just in an amazing place now to help organizations embrace AI generated software development and really secure it with the guardrails without slowing developers down.
Yeah, that slowing developers down, that kind of productivity tax, as we've called it, is something that jumped out to me when I first, kind of came across you and the team, because I was digging into effective vulnerability management and writing about that, and seeing the prioritization problems that we had, and just how teams couldn't keep up. And we'll get into some of that here in a moment. But something you said a moment ago made me laugh, is you said like, we don't really write software, we kind of assemble it, right? And developers are usually using pieces and parts from the internet, and it's like that has never been more true now than it is now. And you said that several years ago when I had you on the show, but now it's like we literally don't write the code, we use tools to help us write the code, which I know we're going to dive into. But the biggest change, in the last, I think it's been a couple of years since we had you on the show or so, there was a big focus on software supply chain security, open source, things like that. Now we see the rise of AI, Gen AI, LLMs that are really kind of changing the landscape. When you look at this and look at the implications of, just this widespread adoption, even beyond just AppSec, but in general cyber, what are your high level thoughts as you're watching kind of what's unfolding here?
Look, it's amazing from a developer productivity perspective, but it's also very, very scary from a security perspective. And I'll just share some stats. It turns out already, and we're in the first innings, that 40% of code in GitHub right now is produced by AI. And like I said, like people are just getting started and scratching the surface. I also like there's a misnomer that AI will just replace software engineers. I look at it more as it will boost the productivity of software engineering teams. It might thereby mean you may need fewer engineers to do the work, but I see AI being fairly far away from being autonomous in writing secure, high quality code for you. But the challenge being from a security perspective, we were already overworked in application security teams, right? The averages are there's like one AppSec engineer for 150 software developers, and you had these security programs like pulled together with band-aid and strings and all of this stuff. It's all going to fall apart. Why do I say that? If you had 1 million alerts being generated a year with the velocity of code you're going to now have, you're going to have 10 million alerts a year if you don't change your tools. You then have statistics showing that there's 62% more security and quality issues in AI generated code. So that problem kind of gets much higher. And the compliance kind of mandates don't shift. And so, unfortunately, these are the kind of situations that end up creating this David and Goliath story where, like, oh, the security people are the bad ones, are slowing us down. But somebody has to pay attention to it. But here's the problem. Billions of dollars have been invested in creating LLMs who can write code. But where is the AI for security teams to combat that influx of code that I just talked about is going to be arguably worse quality and worse security? So I think we're going to see this resurgence of QA and QE, like testing becomes super important, validation becomes super important. And so do code reviews, as an example, right? Like as I have more and more of this code, yes, we might have hey, there's a second reviewer in development required, but nobody's paying attention. Or I talk to a lot of security teams. They have these paper-based threat modeling and security design review programs in place. But what you said on paper versus what AI spit out in code, who's checking that it's in line with your security models and your threat models? So I think it's going to hold this host of issues where your class of known vulnerability-centric problems are going to increase. But most importantly, you're now going to have to pay attention to the non-vulnerability centric or the unknown problems architecturally that AI might create. It might create an API endpoint because you ask it to, but it's left unauthenticated. Now, that's not a CVE, that's an architectural flaw. You might have a database schema where now you're taking in and putting new fields that are PII mandated that somebody needs to have proper governance around. Who's paying attention to those changes in code, right? So I think it's just the influx of a lot more code produced, not necessarily good or secure, is going to require us to very quickly do three things to sum it up. One, have a whole lot more precision in our security scanning tools for code. Two, you're going to have to be left of left, right? Today we talk about, oh, like shift left means doing it on a pull request. Now you got to do it way earlier as Cursor or Copilot is writing that code before it's checked in. You want to be able to iterate agentically with that code to make sure you get it to a point where it's secure well before it's a pull request. And you want to be able to fix it much faster. Again, developers hate changing code because they don't know what the side effects of code changes are going to be. It's easy to say, go upgrade this library, but who's guaranteeing you that upgrade is going to actually work in your code? So remediation and kind of more insightful remediation and telemetry into that becomes super critical. And the third thing really becomes, it's not just a battle of CVEs. It's now all these architectural and security problems that AI can cause.
Yeah, you said a few points there. You kind of stole my thunder of the next question here. Is like, we're seeing some good information come out. I think it was Backbench that showed the security of, these AI generated, copilots and coding tools, and the security of the code that's coming from, as you said, they're largely trained on open source, right? Which we know has, of course, known vulnerabilities, but just also other issues like code rot, lack of maintenance, kind of uncertainty around pedigree and provenance, like, a lot of other factors that I know you guys are big advocates of with the open source software top 10 and things like that. But of course, we have also studies showing that developers are kind of just inherently trusting whatever the AI tools are telling them they're just shipping it and using it. And of course, that's due to longstanding competing incentives with security, like speed to market and feature velocity, and especially if you're in an early stage startup or even a large enterprise, depending on where you are in the organization, how mature it is, and so on. And you kind of touched on this before, but how do we kind of build on that to get to your point of like we're moving towards not just shift left, but secure by design as kind of you didn't say the words, but you're talking about integrating with developer workflows, getting things before they get merged into the code base, those kind of things. What are your thoughts on how we position security in this new paradigm without kind of perpetuating that developer tax that we kind of have lived through already?
Yeah, I think it's a very loaded question, and I'll kind of give you my perspective on that. I think traditionally, application security testing as a market has been focused on detection and reporting, right? Code is written, code is checked in, we run some scans in CI, we find some problems, we create JIRA tickets, and off you go. If you think that was slow and clunky and expensive to an organization, it's going to get a whole lot worse with the volume of problems and volume of code that'll come up. So then that's kind of where I keep going back to shift left of left. So now agents start writing code. Unfortunately, as you said, these agents are trained on open source software. So the commonality of problems and classes of problems will be very similar to what they've trained on. The feedback loop, on one side, you'll have the same problem if you just find vulnerabilities on every library that they recommend or anything. Now you have noise in the system on the left of left, so you didn't really solve this problem well. Goes back to precision. And I think what we found, Chris, is especially there's another class of problems that maybe I should put forward first, which is AI is not just recommending libraries in POM files. It's now taking learnings from libraries and recommending 11 lines of code to you that might be awfully similar and equally vulnerable to some of the package, but you don't even have the lineage of that, right? What about license and legal risks related to that? So we fundamentally believe that a lot of companies that are simply building security wrappers on foundational models and LLMs with no proprietary data or knowledge or insights are not going to survive long term, because eventually those capabilities just get pulled into Cursor, into OpenAI, into Sonnet, into everything else that exists. So I think that the deep rooted question is, what is the company's data moat? Actually, I was reading something last night on Twitter where the founder of HashiCorp said something very interesting. He said, look, there's a lot of companies that are trying to adopt AI, and if you weren't successful without AI, you're not necessarily going to be successful by wrapping more AI around your product. So you got to figure out what is your moat as a company, what is your unique point. And for us at Endor Labs, that has been the deep program analysis that we do of every code base, whether it's the customers or open source, build billions of call graphs to understand and pinpoint issues, have a proprietary vulnerability database that actually understands and annotates every vulnerability to a function level so we can separate what are feature function changes versus security fixes. And that's our deep understanding. So now when I take that and I kind of put it together as an MCP server, for example, that can be used with Copilot or Cursor, the idea is it's almost like pair programming, right? The agent is a software developer. Imagine if you could put an application security engineer next to your developer every single time as they're writing code as pair programmers. And that's the idea, right? The Cursor copilots are producing code. Right away, this agent that's doing the security analysis saying, well, we have context on these 7 lines of code that is being recommended. Here's the problems with it. Even though it might not necessarily be a known library, we can annotate it. We then know what's the best path to fix it. Because we have seen in our experiments, you tell Cursor to go upgrade a library, it tries it 2-3 times, it fails, code doesn't work, it gives up. So, for example, with Endor, we have the context of upgrade impact analysis. Where are the breaking changes? How do you avoid those pitfalls? So as the pair programming happens, what you see in 30 seconds to a minute is code is recommended. We iterate, telling it how to write more secure code. And by the end of that, in a couple of minutes, you just have more secure code. Now, when you put it into a pull request, you're almost guaranteed that you're not going to have stumbling blocks or security blockers along the way. So we think that's the future of AI, right? The agentic, interactive opportunity, but you need context. You need data that goes beyond what the LLMs have. So I think that's the future. And, I'm tremendously excited about it.
Yeah, hey, I am as well. And as you point out, this was going to be my question: is like there's kind of two parallel conversations around AI. One is usually securing the use of AI, and then the other is AI for security. And historically, in cybersecurity, we tend to be a laggard, right? We're late to adopt technologies. Look at the previous waves of cloud and so on. We're very risk averse. But in this case, I think we're starting to learn hard-earned lessons from the past, where we know the attackers are using the new technologies. We know developers and the business is using the new technology. And I think, as you were pointing out, security is now starting to be kind of an early adopter, iterator, innovator of this technology. How can we use it? So I'm curious, like your perspective, both within AppSec and broader cybersecurity. Do you see us kind of avoiding those mistakes of the past, where we're starting to try to use the technology to our benefit, not only kind of sit around and worry about how it could hurt us and harm us?
Yes, certainly. And I think the biggest opportunity here is efficiency and productivity gains because almost every security team on the planet is understaffed, overworked. And I think if you build the tooling less with a, hey, it's an autonomous thing, it'll just go work and you never need to hire people, versus let me go figure out how I can make an AppSec engineer 80% more productive by giving them the tools that developers are getting to do their jobs better. How do I give the application security teams the tools to do their job much more effectively and better? So I think we are certainly seeing that. But there's a opposite problem, Chris, that happens with this. That is kind of the main fallacy of application security and cybersecurity in general, is we end up with too many tools because now there's 50 startups, for example, that are now doing, oh, let me do discovery of models in your code. Well, to us, isn't that just a dependency management problem? Yes, previously you had code from GitHub. Now you have models from Hugging Face. Do you really need to go buy another startup just to do that? And then another startup to pick the GitHub actions and secure the GitHub actions? Like, how many point products are you going to put in your secure SDLC to kind of make it efficient and work and not become stumbling blocks? And then you put too many tools, then you need to buy an aggregation layer like an ASPM because you created a problem, then you got to solve the problem. It's a never ending thing. So I think the way we look at it at Endor Labs, the way I personally have looked at it, even when I built CNAP and Prisma Cloud as a platform, is logically, where do your sensors live? Endor Labs, our sensors are in your code. So to me, the question is, once I have the sensors in your code, when I have the most in-depth knowledge of your call graph, your application graph, your dependencies that are beyond just NPM and PyPy dependencies, but everything in a modern software development ecosystem and estate, then how do I solve a collective set of problems where 1 + 1 starts equaling 3? And so to me, it's really the developer's IDE till you have a shippable artifact, whether it's a container, image, jar, whatever. Like, that is where I would say the scope of what I expect Endor Labs to be focused on and helping our customers with is. And within that, it's obviously a prevention first strategy. As you know, from a couple of years ago, we had Droid GPT, which allowed developers to even explore packages before they started using them. Now you can use that to explore models on Hugging Face and make sure they're secure and up to your enterprise standards before you use them, all the way to now MCP and interactions in Cursor, helping you produce secure code, to precision in scanning, so I can take 90-95% of the noisy alerts away because they don't apply to you in the context of your code that we understand better than anybody else, to remediation. Take, for example, patches. We haven't got to that, but we should, because the age-old problem in security is we report and make it somebody else's problem to fix. And nobody has time for that, Chris, right? And so it's been fascinating for me as we've launched Endor patches to really backport security fixes for hard to fix libraries and uncover that, turns out that 70%, 80% of CVs in the backlog of an enterprise are in like 10% of their libraries. So if we can figure out and solve that concentration problem well, we're again taking the inefficiencies out of the system, removing 8-month, 9-month long upgrade cycles for the sake of checking boxes, and really making our developers more efficient.
Yeah, you said a few things there that actually we're live right now, and someone had put a comment in here, so I'm going to pull it in. Is something you all have also been big advocates of, in the Endor Lab space is, as you talk about prioritization and being more effective around vulnerability management, is they said, one of the biggest issues as these code bases grow with these AI development tools, And a big blind spot is the risk posed by transient dependencies, rather indirect packages and indirect dependencies, they're pulled in automatically through these tools. What are your thoughts around that? As we see this kind of code base, like you said, like 40% of the code is already AI written. It seems like it's going to exacerbate, kind of that problem too as well.
Yeah, I think people underappreciate the problem that transitive dependencies pose. So I'll kind of share a couple of things first and then answer that question. One is, on average, every direct dependency that your developers know they're bringing in bring with it on average 66 transitive dependencies. Yeah, these are the uninvited guests to your house that crashed your party. Uh, the second thing is 95% of your CVEs in a typical customer environment are in transitive dependencies. Now, I've seen some arguments in the industry that says, well, we shouldn't focus on transitive dependencies. It's like, look, it's in your code base, right? And how are you going to go explain to an auditor, like, look, I don't want to fix that. I mean, if there's somebody in your house, it's kind of your responsibility. It doesn't matter if you invited them or not. If they break something, something goes, they light a fire in your house. I mean, yeah, you got to be responsible for that. And so one is, I think we got to understand and appreciate that transitive dependencies really pose an important risk, and they're very complicated to fix because it's not as easy as, let me just upgrade the transitive. Well, you don't have access to that. You got to get to the direct dependencies. So this is where that call graph that I described of understanding your entire state of your application, understand which lines of code are being used, where and how, and those lines of code, are they calling the transitive dependencies, or are the transitive dependencies outside of the reachable paths, become super critical. On average, a very large fintech customer, I'll give you an example of ours, was using Sneak previously, and they were reporting about 2,100 alerts every month to their engineering team to fix. And when they moved over to Endor Labs, they reduced that down to 141 tickets a month. So that's like 95% reduction. So my point is, you need to have the right level of visibility and context first to understand if those problems and transitive dependencies even matter, because they're complicated to fix. Then you need to figure out, how on earth am I going to fix them? And I'll tell you that engineers and dependency upgrades is a bit like using MapQuest still for traffic and directions. Like, it's static. That's not how the world works. Hey, this is in 2.1. It's fixed in 3.2. Go upgrade. It's like, okay, but there's 3.2, 3.3, 3.4, 4.0, 4.1. Do I go to the latest? I don't know what's going to happen to my code. And so everybody's trying, backing things out, rolling back their code, trying again, failing. So what we really need to do is understand that whole dependency graph, direct, transitive, and give them the Google Maps with traffic analysis to predictably say how they're going to get from point A to point B, if there's any accidents on the way. If there are, how are they going to avoid them? And that's what we call upgrade impact analysis, where because we have this call graph of your code and we know where we need to get you to, and there are multiple ways to get there, we will do that simulation analysis and tell you how to get there, including solving problems in transitive dependencies, because it's a pain of engineering existence right now, is dealing with this stuff.
Yeah, it's a kind of a misnomer in many cases for security. Just say, just go fix it, just go patch, just go upgrade. It's like it doesn't work quite that simply in many cases.
I almost feel like that's an insulting statement to engineering, because you're so undermining the effort that it takes for them to fix. And by the way, just on that, last piece I'll make is, there's tools out there that will auto PR a change, right? And frankly, you think creating a PR with a POM XML file change from version 2.1 to 3.1 is hugely interesting? No, because what I don't know as an engineer is what is the consequence of me approving that pull request, right? And merging that pull request. And that's the hard stuff. And so it's just sad reality of the market of security is, like, people haven't gone in and fixed the hard problems, and we're looking to change that. And we think with AI and AI powered tool and pair programming with cursor and things, we can do that, and we can do that really well.
Yeah, I'm excited. I think it's we're headed towards a new generation where we can use this technology to tackle a lot of the systemic problems, whether it's the workforce, being outnumbered, the number of alerts and prioritization challenges, integrating with developers' native workflows to kind of minimize the cognitive disruption that have occurred historically. So I'm excited too. So of course it's conference season. We've got RSA coming up. Black Hat not long after, and a lot of product announcements, and everyone's out there doing industry engagement. I have the website up here, endorlabs.com, but where can folks, catch you guys? What do you have on the horizon? What should they keep an eye out for?
Yeah, exciting stuff going on here for sure. Obviously, RSA is a pilgrimage for many, annual pilgrimage in cybersecurity. So we'll all be there from my team, I'll personally be there. I'd love to meet people. We're going to be parked out at the W Hotel right across from the Moscone Center. If you go to our website, there's plenty of events. There's Lego building evening events and like super cool stuff. So if you're there, look out, check out our website, and look for places where you can come find us. Normally we're at most application security conferences, speaking at many of these places. But also just find me on LinkedIn. I'm usually not as active as you, Chris, but I am there, and I am certainly chatting. And I think there's going to be so much we can all collectively learn from each other. It's a bit like the stock markets. Every time you open Hacker News or Reddit, you don't quite know what got released today in AI, but it could be the next biggest game-changing thing. And I think we all have to keep our eyes and ears on, and collective wisdom on how to leverage it to build better security outcomes is what's most exciting. The other teaser I will leave you all with is look out on April 23rd. There are going to be some very exciting announcements from Endor Labs. So do check us out on April 23rd.
Awesome. You heard it here at endorlabs.com, RSA, any major AppSec conference. As Varun said, learning from the community is something that they're passionate about, and contributing back, giving information, having those conversations. So Varun, thanks so much for jumping on, and thanks to everyone who tuned in as well.
Yeah, happy Friday.
Take care.